In this video, we're going to get onto applying the idea of second derivative in order to solve for different things. And in this case, it's some kinematics. It's some modeling of motion using first and second derivative. So let's read the question and talk about how we do this. An object travels in a straight line, so its displacement from the origin, x is meters per second, t is seconds, and we've got a lovely little equation here. So this says t e to the negative t, where t is any possible number from 0 to 5, and the square brackets mean including 0 and 5. So it says determine an expression for velocity, determine an expression for acceleration, part B, what's the initial speed, part C, determine when the object is resting, and part D, determine when the acceleration is positive. So we should know that when it comes to derivatives, we've got displacement, velocity, acceleration. And if we want to move between these three, then we need to be able to do the derivative, because the derivative is going to move us from one to the other. So if we look at this, the first derivative of displacement is going to give us velocity. The second derivative is going to give us acceleration. So velocity is just the first derivative of displacement, and acceleration is the second derivative of displacement, or you could say it's just the derivative of velocity. So we're going to use that idea right now. Okay, looking at my function, it is a product rule, okay, and it says determine the expression for velocity. Well, we just saw before velocity is just the derivative of displacement. So my u is t, my u dash is 1, my v is e to the negative t, and my v dash is negative e to the negative t. So my y dash, or in this case, it's going to be my velocity, so I'm going to call it that. My velocity with respect to time is equal to v, better write the rule over here for anyone that's forgotten. It is going to be v, which is e to the negative t, times u dash, plus u v dash, and I can tidy this up a little bit. I've got e to the negative t, take t e to the negative t, and I've got negative e to the negative t as a common factor. So what I'm going to do before I keep going is I'm going to make two versions of this. I'm going to have this version and the second version that has e to the negative t as a common factor. There we go. Alright, that is A1. A2 wants to know what the acceleration is as a function. Well, let's do number 2 now. I'm now going to take this function and derive it again. Now what we could do is we could derive that version I've just underlined, or we've just got to derive the second derivative. We can do this function. So I'm actually going to take this function. So my acceleration with respect to time is just the derivative of velocity. So that's a product rule again. So u is e to the negative t, u dash is negative e to the negative t, v is 1 take t, v dash is negative 1. So my acceleration with respect to time is v u dash plus u v dash. Tidy this up a little bit. Negative 1 take t e to the negative t minus e to the negative t. Now again, I've got a common factor here of e to the negative t, so what I'm going to do is I'm going to take that common factor out again. In fact, I've got a common factor of negative e to the negative t if I really wanted to. Okay, I could look at it like that. So I'm going to take out this common factor of negative e to the negative t. That's going to leave me with 1 take t plus 1. So if I take out that common factor, that's what I'm going to get, negative e to the negative t. And this inside of this bracket positive 1, positive 1. So that's actually going to simplify down to 2 take t. So that's part A, determining expressions or equations essentially to represent velocity and acceleration. Now B, C and D is where we actually get into using these. So B, calculate the initial speed. What that means is when t is 0, what's the velocity? Well, I'm going to go back to green because what it's asking you is what is v when t is 0? And all we've got to do is substitute into that equation. So e to the negative 0, 1 take 0. Well, negative 0, that's not a thing, so e to the 0 is just 1, and then 1 take 0 is 1, and 1 times 1 is, well, you wouldn't believe it, it's 1. So part B, that's the initial speed. Now, of course, once it's in a context, you need to put it back in context. So that means 1 meter per second. Part C, determine when the object is at rest and identify its position at that time. Okay, so an object is at rest. An object is at rest where the velocity is 0. So where is e to the negative t, 1 take t, equal to 0. And you'll see why I've put it in factor form. This is why factor form is often king when it comes to these sorts of questions, is when something is equal to 0, we can use null factor law. So where is e to the negative t equal to 0, and where is 1 take t equal to 0? Well, as we know, when it comes to exponentials, that's not possible. When it comes to a simple little linear like this, well, that's where t is 1. So at 1 second, when t is 1 second, is where the object is at rest. The question then says, what is its position? Well, that means we would have to substitute this back into the position equation, which is simply t e to the negative t, so 1 e to the negative 1, which is just 1 over e. So that's my initial position, 1 over e. If you needed this in a decimal, you could, of course, put that into your calculator. Now, better put our units back on. So at 1 second, we are at the position 1 over e meters, which is around about a third of a meter, approximately. Part D now. The easiest way to think about part D is if I want to think about where the acceleration is going to be a positive, I need to first think about, well, where does that acceleration equal 0? Where do we transition from being negative to being positive? So let's first just work out where is this equal to 0. So where e to the negative t, 2 take t, where does that equal 0? And again, we're seeing why factor form is king. We've got null factor law again. Where is it? We've got where e to the negative t equals 0 and where 2 take t equals 0. Well, we saw from before that that's not possible. And then we know that this can simply be arranged to when t is at 2 seconds. Okay. Part D doesn't ask us for what this position is, but simply put, we can simply just work out when that's equal to 0. So we know that that's where it's equal to 0. Now, what we don't yet know is which is positive and which is negative. Well, the easiest way to do a little test is to just test a point either side. Okay, so we could just go test, well, what's left? What's to the left of this? Well, I'm going to test at t equals 0. And then what's to the right of this? Well, let's see if we even need to do that. Let's test at t equals 0. Okay, so a 0 equals e to the negative 0, 2 take 0. So a of 0 is 1 times 2, so 2, and that's a positive number. So what that means is anything to the left of t equals 2 is positive. The acceleration is positive. And that must mean that anything to the right, the acceleration is negative. So, what can we do with that? Well, it just means that we know that, and we can put this in context, acceleration equals positive when t is less than, not equal to, less than 2 seconds. Easy peasy. Why isn't it equal to? Because we know it's equal to 0 at 2 seconds, so it has to be less than 2.